So during the last time we were talking about cryptography, we talked about encryption. We looked at symmetric encryption and asymmetric encryption, and we did some lab on those technology using openssl. So today we are going to be building on that existing knowledge to look at what is hashing, where it is used, and how we can hash a file or a folder, whatever it is you want to hash. So hashing is one of the way that we ensure integrity in cybersecurity. When we talk about integrity, is one of the CIA triad, which forms the baseline of all we do in cybersecurity. If you remember, cybersecurity is all about the solutions we put in place is to make sure we are maintaining either confidentiality, integrity, or availability. So integrity on today, how we maintain it is one of the ways we do is through hashing. When you generate a hash of a file, it helps to maintain the integrity of the file because the value or the digest will change at every given time anything is changed on that file, right? So we say that a hashing is a one-way irreversible process that transforms data into a fixed length. It transforms data into a fixed length alphanumeric strings. So that means, number one, it is a one-way algorithm. Two, it is irreversible. Unlike encryption, encryption is reversible. You can use reverse engineering on encryption to decrypt it as long as you have the required keys, algorithm, and the right file to decrypt. You can do a reverse engineering in encryption and get back original file. But for hashing, hashing is a one-way program, is a one-way algorithm, is a one-way process. You cannot reverse it. Once it's generated, there is nothing you can do to say, okay, let you go back. In fact, what are you even going back to? You got nothing to go back to because what you generated is a digest that represents the current state of the file or the folder that you generated it from. If anything changes, even if it is a period, a space added to that file, the entire thing will change altogether. So we say hash it. That's why it is used to maintain integrity. If you remember, integrity means that we want to make sure that a file is not altered unintentionally when in transit, when at rest, or even in use. We want to make sure the only thing that is altering the file is an expected process, not unintentionally. So if we maintain the integrity of a file, it means that nothing has changed in the file. There is no man in the middle that have changed it. Someone has not mistakenly or intentionally unintentionally changed something in the file. So that is what we use hashing for. First of all, is to provide integrity, looking at the characteristics of hashing. The other one is the one-way and irreversible. You cannot do a reverse engineering on a hash that you generate to get back whatever it is that you have initially. And then same data will always produce same hash value if using the same hash algorithm. That is why it is integrity. At every time, if you generate the same hash using the same algorithm, as long as nothing has changed, you are expected to get the same value at all time. The value will only change if something has changed in the file itself. So any change in the data results to a different hash value. Examples of algorithm that we can use for hashing, we have MD5, we have SHA-1, we have SHA-256, we have SHA-384. These are algorithms that you can use to generate your hash digest. Now, if I generate a hash digest using MD5, and I give you the same file, you use it and generate your own hash digest using the same MD5, we are going to have the same value. If I use MD5 and you use SHA-1, of course, we're not going to be arriving at the same value of the digest. So for you to ensure integrity or to confirm it, you must make sure that the same file and the same digest is the same algorithm is used to generate the hash value. Let's proceed. Now, it's a very simple process. It doesn't take so much time for you to do that. to generate the hash of a file, and we have been using openssl. So here we'll continue to use the openssl. Now, first of all, is we have two options here you can use to generate it. I mean, there are two different commands. It works on both what do you call it, on both Windows and Linux and anything. But for the first option is we will use the set utility. I think the set utility is a window-based utility. So it's inbuilt on Windows, but you can install it on your Linux and your Mac for you to run it. If you don't have openssl installed on the computer, the library, you can just use the set utility file or set utility that comes with Windows to generate your hash value. So here is the syntax of how you can do that. This is the command setutl. Setutl is a keyword, then minus hash file, dash hash file to tell us that you want to generate a hash value. Plain.txt is the file that you want to generate, the file that you want to generate the hash value for. Then here SHA-256 is specifying the algorithm you want to use, and then hash1.txt is used saving that hash value to a file. If you just want to show it on the screen, you can do that. You can show it on the screen without saving it. But if you want to save it, you can now detect or mention the file name where you want it to be saved, and you can go to that file and find your values. Then if you're using openssl, openssl is same command, openssl digest. You specify the hash value, you specify the file name, and then you give it a name that you want to use to save it. If you omit the option of giving it a file name, it will just display the hash value on the screen. And then you can go ahead and maybe copy it or do whatever you want to do with it, however it is. So this is an example or a screenshot of the one generated here. The first one, we use the set utility file, set utility library that comes with Windows. And then here generated it, the new text, giving it a name. Did we give it a name? Okay, that's the file that we are working on, new text.txt. That's our file, and then you generate this, is generated this digest. So if you are sending this file to somebody, the new text.file, you will see most of the time when you go to their website to download the file, they will usually include the hash digest of that file. The reason they include it there is so that after you download the file yourself, you can run a hash digest on that file to see if you will generate the same hash value that was provided. That is how you know that the file you have is the same thing as the one that the initial provider had, as long as you generate the same hash value. And they will always tell you the algorithm that they use to generate the hash value, and you can run the same to see if you will generate the same thing. If you did generate the same thing, it means that you have the right copy of the application or the file. If you don't generate the same, then it must have been tampered from when when the owner uploaded it to the server where you downloaded it from. So these are two examples. Now we'll go ahead and try this in our lab quickly. Let me see if I still have, it's been long I used this laptop. So let me see if I still have and a lot is going on this laptop today, honestly. Let me see if I still have that my encryption folder. That floats away. The encryption folder I had on my desktop. Okay, it's not there anymore. Remember, I wiped that. All right, so let me grab something else. Let me create another folder on my desktop. And I will drag a file into it. Just let me find the right file, because that one we were working with that day, I don't think I still have that file available. I think I lost it. I'm trying to find something we can work with. Let me find a doc file. Let me find a doc file. Okay, let me just do something quickly so we don't waste a lot of time here. I already wasted quite a good number of time here. I'm just gonna find, I just want to copy something to a text file and that I can easily, okay, I'm just gonna copy this. Whatever I can copy, then move it to a notepad. I'll move that to a notepad and I will save that notepad as encryption or anything I want to call the notepad. So on my folder, on my desktop, I'm going to have a new folder created here. I'm going to call encryption. Then inside here, I'm going to save the file as, let me just call it new test over here. So this is the file we are going to be working with. All right, you can see my screen, right?
Yeah.
All right, so I have it installed now. So I'm gonna go into here and do CMD. I have a new CMD up. All right, I am in the folder where I have my file located. And if I do dir, this is the file we are gonna be working with right here. The 5415. If I look at the content of that file, new test.txt. It's just a text that I just copied out of the internet and pasted there, nothing serious. So this is the file we are going to be getting the hash value for this file. And then when we get the hash value, we'll try to change the content of the file and try to get another hash value. So let's try and get the hash value of this guy using the openssl. I would have just used the SAT-UTL, but it's fine. So I have openssl digest. What's this screen? Okay. openssl digest. I'm gonna use SHA 256, and then the file that I want to get the hashing for is new test.txt. I don't want to save it to a file, so I will just do that. So this is the hash value for that file. This is the hash value for the new test. So anytime I generate it, if I use, let me try to use MD5 to generate it, and then you see I'm going to have a different value. I think it should be MD. Don't know if MD5 is still existent, but okay, so we still got a hash value for that. Now you notice that the more hash algorithm that you use, the more longer your hash digest is, because this MD5 has been deprecated actually. And I don't think anybody still uses MD5 to generate hash in these days. So you see it has a shorter length of hash digest, but 256 is longer. Same thing if I try 384 should be giving me something longer than 256 gave me. Let me try SHA 384. So you see SHA-384 gave me a longer hash value. So that's why we say it's a fixed length, depending on the algorithm that you use. So if I change anything in this file, if I'm sending this file to someone and I want them to make sure that the file they receive is the same thing that I have, all I need to do is to run this digest or run this hashing and send them a copy of this digest. tell them this is the algorithm I use to fetch that hashing digest. So when you receive the file, please run the same hashing algorithm to see if to compare the hashing digest you will get with what I sent you. If they are not the same thing, it means the file must have changed while in transit. If they are the same thing, then you know you got the right copy of my file. So let's go and change something in this file, and then we'll try and come and run this digest again. What I'm going to change here, I'm just going to add a period to the end of the file itself. This is the file that I have right now that I used to generate that file. So what I'm going to do here is just add a period to the end of this and then save the file again. I save the file again. I go back here, take a note of the digest that I have, especially I'm going to rerun these guys and see if I get the same value or not. So I'm going to rerun 256 for the same file. And this time around, you see I got totally a different digest just because I added a period to the end of it. If I run it with MD5, MD5 is here, I will get a total different digest compared to what I had initially here. The same thing if I run it with 384, I will get a totally different digest as well from what I did. So anytime you change a value in your file or change anything in your file, expect the hashing digest or whatever hashing value to change, because that is how integrity is maintained for that guy. Ask your questions.
Yeah, my question is so what put the command you redirect it to a new file like new.txt. Is it the new file that you redirect it to? Is it the one that you're gonna send to the person that will confirm it or
Yeah,
what?
the one I did now, I did not direct it to a new file. I just showed it on the screen. If you want to save it in a file, then you
Yeah.
need to add the file name, right? You can just copy the output and send to
Mhm.
the person, or you can save it to a file and give the person anyhow you want to do it.
Okay, so I copied the digest and I sent to the person.
Yeah, you can just copy the digest and send to the person. It's not something that needs to be secret, right? It's not something that needs to be
Okay.
private. That's
Okay.
why if I go to secure website to download a file or a program or an application, you will see that they will usually show you the digest of that file. The reason they do that is so when you get your copy, you can run your own hashing algorithm and compare what the website provided and what you have to make sure they are the same. So it's not something that needs to be kept private.
That's right. Okay. Now I understand today. You to
All
see
right.
that they know exactly how it works.
All right. Questions, question. Question. Ask your question.
Sorry, ma. I think actually I was not the one you posted it. This hashing of a thing, ma, is what's the usefulness, if I may ask?
The hashing is how we verify the integrity of a file. By integrity, we mean to make sure that the file has not been altered, either at rest, in transit, or in use unintentionally. If you remember when we did the CIA triad, we say all that we do in cybersecurity is to maintain confidentiality, integrity, and availability. So hashing is one of the ways that we confirm the integrity of your data or your file or your application, whatever it is. Because when you generate a hash of an application or a file, it confirms that nothing has been changed in that file or program as long as the hashing algorithm remains the same. Like I generated a hash algorithm for this file. If I send you a copy of this file, okay, let me try that. I'm going to send you guys a copy of this file on the Discord channel. Try to run the same hash digest that I did. You will see that you will arrive at the same value. Let me put that file on the Discord channel right now. Um, let me put that file on our Discord channel and you can fetch it from there. Run the same digest that I did and you arrive at the same, at the second one that I did after I changed. Okay, I put the file right there. Feel free to download it, grab it. This is the hash digest expecting you target, the second one I ran. So if you do MD5, you should be arriving at this digest. Someone should try that and let me know, please. Try it. Let me know the hash algorithm you used, and we will compare it with what I received or what I got when I did it. So while someone is trying that, let me keep explaining that again. So that is how we make sure that the file has not been changed, because if anything has changed in the file, you will be getting a total different hashing algorithm or hashing digest or hash value that will tell you that something has changed. Because the goal is to make sure that, if you remember CIA triad, confidentiality will make sure that the file is kept private from prior eyes and only available to authorized users. Integrity is to make sure that the file has not been unintentionally altered, and availability is to make sure that the file or the data is available to the people that to the authorized people that need access to it. These are the three things that we do in all we do in cybersecurity. So integrity means this file or data has not been changed unintentionally. So hashing is one of the ways we confirm integrity. As long as it has not been changed, you're going to get the same hash value at all time if you use the same algorithm for it. Is somebody trying that? Let me know if someone is trying that, please. If you're not trying, let's move on. How do you get the hash from a website so that you can compare it? The cruise. So some websites will usually have their they will upload a file or an application, mostly a .exe file. Then by the side they will always put you the hash value for that file. Many websites do it. I've come across a lot of websites that provides you a file and provide you the hashing, so that you can, the reason they provide the hashing is in case you are in doubt that the file that you receive is not the same one that they provide, so that you receive it, you run the hash algorithm, and then compare whatever you got from what they provided on the website. I know I've seen a lot of websites, especially all these big vendors, big vendor websites that deals with data integrity a lot. They will always provide it. I've come across a lot and a lot of it. Sample website. I don't think I can get anywhere on this laptop that I'm working on right now. But I know of a particular one. I usually see it on that one, but I cannot access that website from my laptop. This laptop is a little restricted from where it can go. That's why I usually don't use this particular laptop. I can access it from this laptop right here. Let me see if I can find another public that I can go to. The place I downloaded the software from, do they have it? I doubt if those. Please, is someone trying this? Are you guys sure? If you're not trying it, let me know so we don't waste time, please. We already wasted a lot of time.
Yeah, I'm trying it. I'm trying it.
So openssl do not provide that. Let me see if I can find another website that provides hashing for their file. And I know I have two in mind, but that too, I can't get to those websites from this computer I am now, because I need to do authentication to access those websites, and I cannot do the authentication from that laptop I'm connected to. Let me see if I can find load file and hash. Is hash. I've already, and is hash digest. How many people are trying to get a hash of that file, please? Is it only one person? I sent it so that you guys can try it out and we compare what I have and what you got. I think Docker should be providing that Docker image with hash. I'm waiting for you guys though, please. I didn't say you should provide it on the Discord channel. Let me know what you got so we can compare it with what I have. This is what I have. Let me know.
Yeah, exactly. I did for the SHA 256, and
SHA-256. So
yeah,
did I do right here? This is
yeah,
for
you did it. You
SHA-256.
start with 1C, and the same thing I saw. So I sent it. The Discord channel. My daughter check it. But the same thing.
Okay.
Yeah.
Anybody else trying? All right. The person asking me websites. If you go to Docker Hub and you want to download the Docker image, the Docker image usually comes with a hash digest. Right now, I can't log into Docker image on this laptop, so I don't want to waste time trying to do that. Then if you go into customer support portal of if you have access to the customer support portal from Palo Alto Networks, before you download their images, you will see their images and their signature applications have the digest provided to you as well. But I won't be able to authenticate to that CSP right now. Okay, so that is it about what do we call it, hashing and what it is used for. The person that was asking the difference or what is used for, I hope you understand now what hashing is used for and why we need it. The person that asked that question, did I answer your question?
Yes, ma'am. Yes, ma'am.
All right, so let's move forward to go back to slideshow. And then we look at digital signatures. Digital signatures. Why I kept this one last is because digital signatures have to deal with a lot of things. It has to do with encryption, it has to do with hashing for you to generate the digital signature. If you remember when we talked about the 5 core principles of security, where we talked about authentication, authorization, accounting, and non-repudiation, where we said that non-repudiation ensures that someone that did something or interfaced with a file or a data will not come back later and deny that they interfaced with that file. So how do we ensure that that doesn't happen, that someone that did something doesn't come back again and say, I did not do this again? And that is by appending a digital signature to a file. That way we ensure non-repudiation. You won't come back and say you did not do again when your digital signature is part of the file itself. There are some organizations that will force you, if you access the file, before you can get out of that file, you will sign that file with your digital signature. That way they know the last person that had access to that file. And you will mostly see that when you are doing forensic, when you are into a forensic and digital forensic analysis, because there's what we call a chain of custody. Chain of custody is when you're collecting an evidence, you need to keep a chain of custody of how where that file has been, who interfaced with it, who used it, and then you need to verify each time the person uses that file, someone uses that file. So anytime you interface with a material that is supposed to be used as an evidence, you must sign it with your digital signature, so we know that you worked with it, what you did with it, before you pass it to the next person. So digital signature, we say, is a cryptographic virtual fingerprint, just like you append your fingerprint that is unique to you or unique to an entity, and we use it to validate the authenticity and integrity of a digital asset. So digital signature is also can be used to validate the integrity of a file. It can also be used to confirm the authenticity of a file. It can also be used to ensure non-repudiation. You cannot come back and tell us you did not do again when it's obvious your signature is there. And why we know that you cannot deny signing it is because before you can sign any file with your digital signature, you have to use your private key. And you remember that private key is private to the owner. Nobody else have your private key. If your private key is compromised, it means you have to change it because someone can actually use it and impersonate you. So when you have your private key and it's all you that have the private key, we know that no one else can generate a digital signature with your certificate, with your private key, if not you. So you encrypt your digital signature with your private key and another person can decrypt it with your public key, because your public key is public, anybody can have it, but your private key is all you, no one else have it. So that is where we know that if you actually signed a digital signature with your private key, you cannot come back and tell us you did not do again when it is your private key that was used to sign that signature. So what are the characteristics of digital signature? One, it requires the hash of a file or a data. So before you can even sign it, you need to generate the hash of the file or the data, or the hash of the file or the data that you're trying to sign. Because the hash is what we try to encrypt with your private key, and then someone can decrypt it with a public key. So it uses your private key for the encryption, uses your public key for the decryption, and this guarantees the signer cannot deny signing the data. And we use it to invalidate if a file or data is altered. If that data has been altered, of course, when you try to decrypt it, it will say that the signature is no longer valid. If I give you a file right now and I change the content of that file, even after I have signed it, if you try to verify my signature, it will tell you that that was not the file that was signed because that file has been changed. So once you change a file and then you try to verify the signature on that file, it will obviously not match the original one, and it will tell you verification has failed. So let's look at how we can actually generate a digital signature. Anybody got a question?
Yeah, I got a question.
Go ahead.
So so talking about the keys, like public key and the private ones, do you mean uh I mean the key for your Windows?
Huh?
Do you mean, I mean, are you talking about the Windows key, like the certificate that we have while installing the Windows or the Linux? Are you talking about that?
Were you here when we did symmetric encryption and asymmetric encryption?
I was here.
Okay, so because I find it funny you're asking me that. The
No,
private key and
in
public key
this
I'm talking
particular,
about is the same
in
key.
yeah, in this particular scenario that we're
Mm-hmm.
talking about, yeah, that's what I'm asking you.
No, it's the
Because
same.
you talk in general, so you talk in general and then specification. I just want to know exactly in which scenario we are in.
This is the same asymmetric keys that you generate. The same private and public key you generate for asymmetric encryption. That's the same key we're talking about. That's the same private and public key.
Okay, okay.
It's
So
not
it's just for a particular operation, right?
this is a cryptographic key for encryption and decryption.
Okay. All right. I understand. Okay. All right.
All right, any other question before we continue? Question? All right, so the process or the steps for us to generate a digital signature is, first of all, you need to have a file that you want to sign. You need to have the data or the application or whatever it is that you are trying to sign. And then you generate the hash of that file. You generate the hash of that file and you sign the hash. Remember, we are not signing the actual file. We are signing the hash value with the private key. Once you sign it with the private key, you will generate the signature file. Now we have two files. You have the original file that you signed, you have the signature file. To make sure that we are able to send this to the person securely, you will send the algorithm that you use to sign the key. You need to sign the signature file. You send the signature file, you send your public key, and you send the original data to the recipient. Now, so what some people will do is they will put all this, the algorithm, the signature, maybe the public key, and the original data. They may zip all of this in one file, in a zip file, and then encrypt that zip file, just so you know you're sending it securely. But if you don't need to bother about sending it securely, you can just send the person the algorithm you use, send the signature file, send the public key and the original data to the recipient. Now, none of these actually, it doesn't even matter if you encrypt this entire thing, because none of them is meant to be what do you call it? Or what am I looking for? Private. It doesn't have to be private, especially if you have encrypted the original data. So some people will start with the original data they have here. They will encrypt the data even before they generate the hash of the data. So when you are sending to the person, what you are sending to the person is the encrypted file that you send the person. So when the person receives the encrypted file, they will receive the public key, which anybody can have, the signature file, they can receive it, the algorithm that you use for your encryption, and the algorithm you use for your hashing. You will send all that to the person, and then the recipient will use the details that you've sent to verify the signature and ensures that the data has not been changed. Like I said, there are two things here. If you're bothered about security of the original file, you can encrypt the original file and then generate the hash of the original file. But if you're not worried about security of the original file, not security, you're not worried about the privacy of the original file, that all you're worried about is integrity, then you can just generate the hash file of the original file. That will give you you will now sign the hash file and generate a signature file. So now, right now you have two files. You have the signature file, you have the original file, you have your public key, which you must have sent to the person. If you have not sent to the person, you can send it at that moment. And then you also mention the algorithm that you use to sign the file, so that the person can use the same algorithm to confirm the authentication and integrity of that file. So once you, the original person, gets all this, what the recipient will do is to use the detail that you provided to confirm that whatever you send is still what they're expecting and it wasn't changed while in transit. So let's run through this process quickly. So first of all, here is generate the hash value and sign at the same time. So openssl allows us to compress this process into one operation. Instead of you generating the hash differently and signing differently, you can do two of them at the same time. You can generate the hash file at the same time, sign that hash file in one command, instead of having two different commands to do that. Because if you go through the route of doing it differently, I think I was trying to do that at some point, but it wasn't letting me, because the latest openssl version have it only have that one command for you to do it, unless if you're doing it with a different utility. But for openssl, the best way is you generate the hash at the same time, and then you sign the hash at the same time while you're generating the hash, instead of doing it differently. And the key that you use to sign the hash, it could be maybe a public key, it could be your, no, it's not a public key, it has to be your private key. That's what I said. It's if you're doing the encryption of the file initially, then you can encrypt with maybe a symmetric key, or you can use your asymmetric key to encrypt. But here, look at this command. In this command here, we are trying to generate the hash and then sign it at the same time using our private key right here. So this is the command right here, openssl digest. The SHA-256 shows the hashing algorithm that we are using to generate the hash value, and then sign, this is our private key that we are using to sign the file, and then out is the name of the file that you signed. Then the last one is the original file that you've signed. This out plain will be the signature file. The plain.txt is the original file that we signed. Well, at least when you see out, whatever comes after your out is the signature file that you're generating. The last file name right here is the original file that you're trying to sign. So here we have the algorithm, the hashing algorithm that we are using. Then we have our key that we are using. This key must have been generated initially. If you don't have the key, then you generate the key. And then you have the out plain sign, which is for the signature file. And then the last one here will be the text file, the original file that you're trying to sign. Now, these are the files you will send to the person once you are done with it. You send the original file, you send the signature file, and then you send the hash, which is SHA-256. Remember, you do not send them your private key that you use to sign it. Rather, you send them your public key that that one that is public, anybody can have over there. So here is the command right here. First of all, this is my private key, this is my public key, this is the original file that I wanted to sign right here. So the command is just that, the same one that we said here. If your key was generated with a passphrase, of course, it will ask you to put in the passphrase for your key. And then once it does that, it will generate the file. This is me trying to view the content of the signature file. So this is what the signature file looks like, if you see right here. So we're going to try to follow this same process and generate the file. And once you generate the file, you will send the signature file, the original file, and the hashing algorithm you use. The person will now use it to verify whatever it is you sent. And for the verification, it is another one command, verify the signature with a public key. So here, Open Digest, you see we are using the same hashing algorithm, but now we are not signing, we are verifying, specifying the public key that matches the private key that we used. And then the signature file. This is the signature file we generated, and then comparing it with the original file that we try to verify. So once you do that, if the signature is correct, you will receive verified OK. Verified OK means everything matches well. You use the right public key, you specify the right signature file, you specify the right original file, and you specified the right algorithm. Once all this matches, then the user will use it and say verified OK. If you don't get verified OK, then there could be a problem. It could be that you use the wrong public key, you use the wrong signature file, or that the original file has been changed or tampered, or something has changed in the signature file or the plain file, which is original file, or that you're not using the right digest to try to compare or trying to validate the signature on that file. So once the person signs that, you will not come back and tell us that you did not sign again when we can obviously verify your signature on the file using your public key for that. Ask your questions before we go into the quick lab. Ask your question. Question. Ask your questions. I don't think I have any key here. So we have to generate some public key and some private key that we will use. So what I will do is I'm going to sign the file. I will put the files, my public key, the original file so that you guys will verify. So let's go ahead and generate a key. I don't have any key in that folder anymore because I know I wiped everything on this laptop at some point. So this is the only thing I have here, this file. This is the same file I'm going to try to use. So we are going to generate a private key, a public key here, and then we try to sign it. Let's find that command to generate a key. I think I have that in one of these slides. Symmetric encryption. No, I'm not using symmetric. Asymmetric. Yeah, create a private key. Okay, so we're going to create an AE5 private key, and then we extract the public key from it. So let me bring my folder right here. Not my folder, my CLR here. I think it was it. Okay. So I'm going to be in the same folder where I have my file, because this is where I want to drop my file. I'm going to use the short command. I don't want to go the long command. What's the difference between the short and long command set? Nothing. I'll just use the short command. All right, so let's generate the key right now. I'm going to use openssl. I'm going to use gen RSA. I will do AES 256 each. Why am I uncle? 256. The name of my key, I'll just give you the same name. nkey.pem. And I'm going to, the size of my key will be 248, but the file is not that big, so key 248 should be able to work for us. I'm going to give it a phrase. Let me just save it with CCNA. Sorry. CCNA will be my key. Always remember your passphrase. So if you forget your passphrase, sorry for you. So this is my key that I created right now, my private key. We already went through how to do this and why, which was just that I had to collect the command from here. Yeah, I'm not used to having command in my head. As long as I know when I want to use it, I will find how to use it. The problem is if you don't know when and why you're using it, but the how, you can always get the how anyway. So this is the key that I got. Now let's go and extract the public key from that. We run this command to extract the public key from our private key. Of course, I did it with what did I just create? Yes, I created a private key. So let's extract the public key from the private key right here using this command. And that will be openssl RSA. In the key name that we are trying to extract, we're going to from nkey.pem, and then showing that we are doing cobalt extraction. The name of my key, I'm going to call it nkpub.pem as well. Hit enter. My original key was CCNA. Okay, if I do dir, so I have my private key. Oh shoot, I typed Gomumbo. Let me regenerate that. I don't like that name. I think I typed the name wrongly. Yeah. It should be nkpub. Yeah, right there. CCNA. So if I do dir, I have my public key, I have my private key right here. So we have the two keys that we need for us to do the signatures, the signature encryption and decryption. I have the two key right here. So let's go ahead and use it to sign the signature, and then I will send you guys the details for you to verify. So I'll go back to that page that we were on right here, Okay, right here. Okay, so we'll go ahead and generate the signature file and sign it, of course. I have the file. This is the file I want to verify. This is my private key. This is my public key. So I have all the details that I need right here. Now let's go ahead and sign this file. So what we're going to do first is generate the hash file, the hash value for this file. The hash value is what we are going to sign with the private key. And then we generate the signature file with it from here. So let's go ahead and do that. openssl, digest. I'm going to use SHA-256. You can use anyone, maybe MD5 or SHA-348. I'm going to use 256 as seen here. 256, and then showing that I want to sign that file. What key do I use? I want to use nkkey.pem, which is my private key. Remember, you cannot use your public key to sign a signature. It needs to be your private key. That's how we hold you accountable. And then out, which is the signature file now, I will call it what name will I give it? Let me say signed file. I'll give it signed file.txt. And then the original file I'm trying to sign is new test.txt. This will prompt me for obviously the passphrase for my key, which is CCNA. All right, if I do dir, I have my signature file right here. So what I'm going to send you the signature file. I'll send you my public key, and I already sent the original file in the Discord channel. So make sure you put this signature file and the public key and this file, put all of them in the same folder. Then go into the folder and try to run the command to verify my signature. I will put these files right now in the Discord channel. I'll put the signed TXT, I'll put my public key, and then you already have the original file. So I'll put that now. You try to run the command to verify it, to verify my signature. I'm dragging that file. This is my signature, this is my public key. Right about now. All right. Please don't make any change to the file. Just download the file and put all of them in the same folder and try to verify it. If I try to view the contents of that signed file, signed file.txt, you see it's all scrambled. It's all scrambled, so you can't even read it. This is the content of the signed signature file. So this is my signature file right here. If I try to verify this, I need to run the command to verify the signature. And this is the command right here. openssl digest 256. Remember, that is the algorithm we use. We shows that we are trying to verify, and then you put the public key. Remember, you're putting the public key or not the private key. I didn't even send in my private key anyway. So, and then signature, you're verifying the signature of this file from the original file. So someone should go ahead and run the command, try to verify it, and let me know what you got. In the meantime, I will also try to run the command to verify it, since I have all the file in this folder already. So let me try to run the command to verify the signature. openssl digest. I'm using SHA-256. Showing I'm trying to verify a signature, and then I specify my private key, which is nkpub.pem. And then what's my signature file name is signed file.txt. What is my original file? My original file is new test.txt. So you see, it's telling me verification okay. So it verified that everything is fine here. Nothing has been changed. Can someone do that with the files I provided and let me know if you're getting okay? While we are waiting for that, ask your questions, please. Ask your questions while you're doing that. Ask your questions. Wait, I didn't lose my Zoom session, did I? Is someone trying that or no, so that we don't waste time?
Yeah, I'm trying it. Let me see.
Okay. Try it and let me know. While you're trying it, let's go ahead and make a change to the original file that we had. This is the original file that we had right here that we verified. I'm going to go ahead and take away this last dot here. Just the first one, I'm going to take it out and then I'll save the file. So let's try and verify again this file and see if we succeed or if we fail. The same command that verified, I'm not making anything on the command, I'm just going to hit enter. And now I'm seeing verification is failing because it noticed that the original file is no longer, has been changed. The original file has been tampered with. So it has changed from what was used to generate the signature file. So Felix, if you are getting it, if you're trying to verify and you have all the files that I gave you or I provided on the Discord channel, you will say, okay, if you get verification failure, then we have to troubleshoot. Something must have gone wrong in your end.
Yeah, I'm having issue with it. I did let me recall about the comment that I did. I did openssl digest slash dash 256 that verify nk dash pub dot pem dash signature, right?
Mm-hmm.
Signature signed file dot txt
Mm-hmm.
space new test dot txt. That's what I did.
What error are you getting?
I'm getting default library context algorithm 256.
Did you push SHA-256?
Yeah, I did. Let me. Oh, sorry. Yes, I made a
Okay.
mistake. Yeah. Okay, I just put 250. Sure. Okay, I got. Okay, good. It's
All right.
working. Thank you so much. Yeah.
All right, so that confirms that the files
Oh,
I sent you is correct and you received the right public key, the right signature key, and then verified it. So there is no way somebody will go through this
yeah.
and verify the file with your signature and you come back and tell us that you did not sign it. That will not happen. That is where we have that saying in Nigeria that say you go explain, there are no evidence. This one there is evidence. So there is no need for you to do too much explanation when
Yeah,
we have
exactly.
evidence to catch you red-handed. All right, ask your questions. Ask your questions. Let's look
Um,
at, go
one more
ahead.
question. One more question. So you said for security reason we can also zip the file and send everything together with the person to the person, and then the zip file will be encrypted, right?
Yeah, you can see if you're worried about privacy, you can put all those files in a folder,
Yeah.
zip it, send it to the person. then that one what you can do there, you can encrypt it with your private key, and then the person will first of all decrypt it with your private key. When they decrypt it, they will now find the entire file inside the folder, and then they will now try to verify your signature using your public key again.
Okay, makes sense. All right. So the person will do two jobs. Like first of all, decrypt the file,
Yes.
the zip file, and then decrypt it.
Yeah, you first of all decrypt the zip file that
The zip
has the
file.
signature file, the original file, your public key, which I don't know why somebody will encrypt a public key, because it's public, you can give it to anybody. But where the security lies is on the plain text, which is the
Okay.
original file.
Yeah.
So because even the signature file is encrypted, you can't read it. The signature file itself is encrypted. So even if you get it, you won't be able to read it. It's all scrambled. So it's only the original file that is usually where the issue is. That is if it is not encrypted already. But if you don't want to put all of them in a zip file and encrypt the zip file, you can just encrypt the plain file, the original file, then work with the encrypted original file. So you hash the encrypted file and provide the user that way you don't have to send them the original file. You just send them the ciphertext of the file that you encrypted. That means they have to first of all decrypt, verify the signature, and then go ahead to decrypt the file itself after.
Okay. Thank you.
All right, questions. You guys are too silent and I don't like it. Please ask me your question. T1, Solomon, Emmanuel, Samson, God's will, Simeon. Ask your questions, please. Who have I not called? Ask your questions. Abbas, ask me your questions now, please.
Yeah, I'm kind of lost a little bit.
You will tell me if you say you're kind of lost. How am I supposed to know you're lost if you don't ask your questions? You're not asking your question. Okay. I believe you don't want to. Now let's look
No,
at.
it's not. It's like, oh yeah, I had an emergency call, so I didn't follow the beginning. So like, I'm, yeah, I don't know if it would be appropriate if I take you all the way back. So I think I might watch the video. I don't know.
Okay. That's okay. That's fine. So let's look at what are the reasons why your digital signature verification will fail. Like I said, if everything goes well, you should get verified okay, meaning of everything is fine. Otherwise, you will receive a verification failure, which we already tried here. So how we simulated this failure is we modified the original data. We removed the period at the end of the data to simulate the failure. So what are the reasons that will make this fail? Is either you're using a wrong or mismatched public key. Remember that the public key and private key are mathematically paired. So it has to be the same key. It has to be a public key that was extracted from the same private key that was used to encrypt the file. Or the original file has been modified, just like we did. We modified the original file and then we couldn't verify the signature anymore. Wrong or modified signature file. Even though the signature file is encrypted itself, you can't read it. Someone can unintentionally or even intentionally delete something from the file, even if they cannot read it. Although they can't read it, but they can modify the content of the signature file. And then it will cause the verification to fail. So any of these will cause your signature verification to fail. Otherwise, you should be having a successful signature check. And that is all I have on cryptography. Please ask your questions. Ask your questions.
So, if I understand, we are going to be using mostly the SHA-256 and asymmetric encryptions, right?
Yeah, this is for you to do this digital signature. It's not a must. You must use SHA-256. Like when I did the hashing lab, I used MD5, I used SHA-348, I used 256. You can use any of these algorithms. It's fine. It doesn't have to be 256. You can use any of the hashing algorithm. Then for the verification keys, it has to be your private key. So you are using asymmetric keys, the private and your public key, because that is how we can hold you accountable. Your private key is your property. Nobody else has it. So if you signed a file with your private key, then we know that you are the one that did it. But anybody that have your public key can use it to verify the file that you signed. So it has to be the asymmetric keys, mathematically paired private and public key.
Yeah.
Questions, questions, questions. Hey, Cyber good morning, good afternoon, happy Sunday. How are you doing, brother? Ask your questions, please.
So, I was asking, so in a cyber war, so is it something that you'll be doing on a daily basis?
It's not something like you do in daily basis. I am a network security engineer. I have never have to verify this in a customer environment, right? So it depends. Mostly people that would do this, somebody who is doing digital forensic, that the one that will be doing this on a daily basis. If you're doing digital forensic, because that is how you need to maintain the chain of custody of every file, and this is one of the way they confirm who handles the file, so that to make sure that the file is still admissible in court.
Okay. Got it.
Questions, questions, questions. Please ask your questions. That's all I have for cryptography. We are going to do more on cryptography, but that will be when we start on the specialized area, when we do certificates. That is what is left of cryptography, but it's not part of the foundational, because if I generate a signature now, I will start asking, you guys ask me a lot of questions about what type of signature it is, because we have different kind of signatures. We have certificates. We have server certificate, client certificate, certificate authority, rules registrar, intermediate certificate. There is quite a lot of certificates. That is the one that whichever field that you are in cybersecurity, you are going to be using it every time. Certificates, you can't escape certificates. Whichever field you are, you're going to be dealing with certificates a lot. So ask your questions, please. Ask your questions.
So if you have to summarize it, and what we just did today, like from start, I just want to have yeah.
So we started with hashing algorithm and how we use hashing to maintain or prove integrity of a file. When we talk about integrity of a file, it's the assurance that a file has not been modified, either in transit, at rest, or in use unintentionally. Of course, we expect a file to be changed at some point, but then let it be a legitimate change, not an unintentional change. So integrity is how we maintain we confirm that a file has not been changed unintentionally. And one of the ways we do that, we looked at hashing. When you generate the hash of a file or the hash of a data, as long as that file or data has not been changed, the hash digest or the hash value will remain the same at all time, even if you generate it again in 20 years time. As long as nothing has changed and you're using the same hashing algorithm, you will arrive at the same value at all time. So when you're arriving at the same value, it is an assurance that that file has not been changed and have not been modified. Once the hashing digest changes, it means something has gone wrong with the file. Either it has been intentionally or unintentionally changed, but it is no longer the same file that you had when you did the previous when you generated the previous hashing value. So we walked through how to generate those hash values. using openssl, and I think Felix confirmed it as well. I sent them a copy of the file. They generated the same hash. They generated a hash using the same algorithm and arrived at the same file as the same hash value as well. So that confirmed that the file has not been changed. Then we move through to look at digital signature, which is another way we ensure integrity and non-repudiation in cybersecurity. Non-repudiation means that is an assurance or a way that we maintain that someone that interfaced or had access to a file or a data will not come back and say they no longer had access to it. So you cannot deny having interfaced with that file or that data, because you are expected to sign the file with your signature. So for you to sign a file with a signature, digital signature, you need your private key. Understanding that only you have access to your private key, nobody else. So if you sign it with your private key, it means that you interface with it and anybody can verify that signature using your public key. So that's what we did by digital signature. But for you to sign it, you need to generate the hash value. Sign the hash value of the file with your private key, and then you can send the hash value, which is in form of a signature file, send the original file, and send the algorithm that you use to the people or whoever wants to verify it. And then they will use the detail and run another command to verify your signature. If we verify your signature, you cannot come and deny that you did not sign it. The people in law say it's no, what do they say? Ignorance is not an excuse for one thing. I don't understand. So that is the same thing that do happen here. Even if someone gets hold of your private key, it is meant you were expected, or the requirement is that you keep your private key secret from anybody. So if somebody gets access to it and use it to sign a file on your behalf, you cannot deny that you did not sign the file, because it is your private key. You are the only one that is meant to have it. So it makes it very, very important that you keep your private key secure and safe from prior eye. Whoever it is, nobody should have access to your private key, because they can use it to implicate you unnecessarily when you have not done anything wrong. So that is what the digital signature does for us. Does that make any sense?
Yeah. Yeah. So when you say if the file has been transformed unintentionally and intentionally, how can that be like how the file become intentionally you know modified?
Yeah, so if you have a file, sometimes you edit your file intentionally. Maybe you have a doc file, especially if it's a living file, a live document that is meant to change at all time. Maybe it's a change, what do you call it? A change history file. You meant to update every time you make a change. So every time you make a change, you're done making the change, you can generate a hash value of that and keep it. Next time you update that file, so you update your files regularly. There are some files you update regularly, like your resume, the resume you have 10 years ago is not the same resume you have today. You have updated something in it. So when you do that, that is an intentional change. You meant to make that change. And when you do that, you can go ahead and generate a hash value of that and keep it, so that tomorrow, maybe something happened and you got a different copy of your resume, you can run the same hash value to confirm the last change that you did and save if it was you. So usually files will be changed intentionally. That's okay if you change intentionally. The hash value is how we make sure that it wasn't changed unintentionally. So if you run a hash value, there are some applications that before they will process a file, you will give them the file and provide the hash value of that file. Before they will make modification to the file, they will first of all run the hash digest to confirm the authenticity of the file before they make a new change to it. And once they make the new change, they will also generate a new hash value and keep it handy for future references. So as you go, it is expected that files will change, content of files will change, but make sure that the changes are legitimate changes by generating a hash value and keeping it handy in case of tomorrow. Does that answer your question?
Yeah. So now if you wanna get the hash value, is that what you have to use at openssl? Like
This is the command to get a hash value.
okay,
Right here, we have two options. You can use the certificate utility that comes with Windows if you're on Windows, or the general one that is accepted by all operating system, openssl. You can use any of them to generate your hash value right here. So this is set utility hash file. You provide the file you're trying to generate the hash. You provide the hashing algorithm, and then this hash one is the name of the file where you will save the hash value if you want to save it to a file. If you don't want to save it to a file, you can just ignore that last option with the symbol there. Just enter to the algorithm, just like I did in this example. So in this example, I tried to do the set ETL here, and then I did not specify the ending file name. So it just displayed the hash value to the screen. But if I wanted to save it to a file, then you need to add the last option here that saves it to a file if you want to save it to a file. Otherwise, it will just display it on the screen for you. You can copy it and put somewhere if you want, or you can just save it to a file, however you want to have it handy. So this file you generate here, in 20 years, if I get this same file, new test.txt, as long as nothing has been changed from the last time I ran this command, and I run this command again, I will still arrive at this same value right here without changing it. Nothing will change. If anything changes on the file, then the hash digest is going to change. Does that answer your question?
Yes, thank you.
Ask more questions if you need to.
Hello, ma'am.
Go ahead.
In the process of trying to hash a file, if the original file is corrupted, how can you restore or go back?
If your original file is corrupt, then you should have a backup now. You should get a backup of your original file before you start hashing.
Hashing, okay.
You mean if the hashing process is the one that corrupted the file?
Yes.
How is that? How will hashing process corrupt the file? You're just generating a hash value. Doesn't make sense. It's corrupting the file. It doesn't even encrypt the file. It just gets a hash value of the file. So there's no way to mess up with the file. But if peradventure it does, then you need to get the original file again and hash it. But it's not something that happens. I've never had that hashing corrupts a file.
Okay. All right. Thank you.
Questions? Questions. We are rounding up. Kaiba Creole, rest, Equano. Brother, rest now. True. You want to verify my authenticity when I come online. All right, so if you don't have any question, I will see you. I'm not in the honestly. This thing that happened this morning with the change of laptop just scattered my entire plan for the day, and right now it's gonna take me a little time to reconstruct my head on what I have to do for the day. So I don't think I'm in the mood for a Kahoot game today. I'm sorry. That usually happens whenever I plan my day and then something else messes up. It takes me a little while to recover. So right now I am not in the mood for a Kahoot game, so we're going to leave it for next week. Even though I know I have a game ready, but I'm running it right now. I won't do that. So let's leave it for next week. Your any other question before I stop recording? questions regarding this before I stop recording? All right, let me stop recording.